Good morning, good afternoon, and welcome to the ninth session of the Cloud Mentorship Program. The topic of today is the automation and orchestration. So, as you all know, the goal of the overall program is to do this kind of skill set or reskill thing, or the enablement for you to take like your steps toward the cloud domain, having the relying on the principles from the telco background. So the explanation of automation and orchestration will come here from telco perspective. It will give you like a good, I would say, a good foundation to start dig into these topics and go deeper to any topic that you might be interested in. We will also browse some buzzwords that you may always hear when you read articles or you interpret technical content on LinkedIn, for instance. So hopefully we can cover that in 15 minutes. So just please put yourself on mute and we can start. So I chose a starting point that I usually do, because it's very vital for telco professionals, or even for cloud professionals, or anyone working with telco enterprises to understand the enterprise anatomy. Because many technologies exist in different domains. They may coexist together. So you might have heard maybe the term orchestrator in many domains. It's a trending term in cloud domain, but also you can find it in another domain, service domains. Sometimes if you go to BSS, to customer domains, you always get the same term. So that's why I will start with giving an introduction about what kind of domains, what kind of processes, what kind of teams that you may find in a telco enterprise. And then we will identify the orchestration spots. While we're doing that, we are going to give somehow a definition, what's exactly an automation, what's exactly an orchestration. So let's start, and the reference here is the TM forum, information framework domains. That's how the TM forum draw the different domains constructing an enterprise. And if we scan these domains from bottom to top, so we have the enterprise domain. That's actually the internal domain of the telco or any enterprise, the one that have the like human resources and any kind of internal process related to the way of work or the workforce inside that enterprise. That's actually the enterprise domain. We have the partner domain, and that includes all the processes and all the workflows that govern the communication with any partner, with any third-party partner. For example, if you are a company delivering a basic router, then most probably how you dispatch this router or dispatch this CPE to the customer. So there is an entity in the middle, a partner who's doing this kind of dispatching. So how you engage or how you govern the communication with that partner, this kind of process is there in the partner domain. And then you have the resources domain, and that maps to the infrastructure domain. Like, for example, any domain or any enterprise that works with passive elements, with servers, even the cloud itself, it's part of the resources domain. And any other kind of resources you find in that in the resources domain. And then the service domain, that's most of our the colleagues here and the teams are working. That's like, for example, the domain that possesses certain service like voice service, data service, and that maps to teams like the packet core, the circuit switching, the IMS, the bases. So all these kinds of services are grouped into a service domain. And then, and also in service domain, you start to hear terms like service assurance, service provisioning. So all these kinds of activities, tasks, processes are there in the service domain. And then you have the customer domain. And there in the customer domain, you find everything related to customer handling. You start here to meet the terms like the BSS. You see the billing of the customers. You see the customer order management. You see the customer problem handling. So all these kinds of processes are there in the customer domain. And then you go to the product domain. That's where you get processes to create products. You hear terms like product lifecycle management. You get, let me just admit, Abdurrahman. As I said, product lifecycle management, you get the way you develop bundles for your network for your customers. For example, you get product A and product B, and then you do a bundle, and then you go to market with this bundle. So all these processes you find it in the product domain, and then the market sales domain, you find the digital channels, the applications, the marketplaces, how actually you sell your product, your service. You find your sales team and market team. And it's a joke, but you may assume that going from resources domain to market sales domain, you get your salary somehow increasing. So people in working on resources domain are all like engineers wearing jeans and polo shirts, and then people are there in the top, they're wearing suits and formal clothes. It's a joke, but more into the reality. So these are the domains that exist in any enterprise, and specifically we're talking about telco. So you find all these 7 domains in the telco, and most of the organization structure is very aligned to TM forum information framework domains. So these are the horizontal domains. In the same time, there are vertical processes that actually cut or that is actually traverse all these domains. You have what we call end-to-end level 1 vertical process of strategy and infrastructure product, that you'll find all the logic about putting a strategy, defining a product. And then we have the OSR, the operation and support and readiness. That's where you get things like the catalogs, things like the processes related to for example, the templates, the modeling, you find it here in the operation support and readiness. And then you have the fulfillment, and that term is very trending in telco. Fulfillment, you will find terms like order management, service provisioning, whatever kind of fulfillment, you find it in that kind of level 1 processes. And then you have an assurance that actually cut all the domains. For example, if it cuts the service domain, you'll find terms like service assurance, like the systems that provide assurance in terms of fault management and performance management. And then you have the billing and revenue management. For example, how do you meter, the usage of your cloud? That's kind of part of the revenue and billing management. How you do the actual billing. So you see in the customer domain, when this process cuts the customer domain, you'll get the customer billing. So usually the intersection or the cuts of these level 1 vertical processes with the corresponding domains, usually it creates either the products that you need to purchase, or it formulate the teams and the departments, how they are structured. This is like the foundational on how you structure a telco organization. For sure, this might change by time and by the new reorganizational stuff, but that's how we used to build the organization of the telcos and the corresponding logic. So now it's time to see actually the poster, okay, the intersection of these processes and the domains, and I'm sure you will find a lot of words that you have seen before. So let's take that step. And now when we do this kind of intersection, that will draw the well-known poster of TAM, the Telecom Application Map. And that's the name of the publication that I'm referring here, that TMF GB929. And TMF GB929, it basically that well-known poster, it shows to you the intersection of these processes with these domains and what kind of we call it level 1 and level 2 tasks or process that it triggered. It's a huge poster, and for sure I will not bring it all, but at least I brought to you. I focused on 4 domains, like resources domain, service domain, customer domain, product domain, because most probably our work will always be in the resource, service, and customer domain. And let me show you now what I meant by showing this kind of, by telling you that there is kind of intersection. So for instance, if you see the strategy infrastructure and product, the level one processes, that the intersection with the service domain, you find the capability of having a service catalog. In the resources domain, you have the capability of having resources catalog. In the product, you have the capability of product catalog. So the term catalog is very important term that I'm sure that any one of you work with an administrator or within the BSS side, you always see that term there, the catalog. So the catalog is actually where you define your services, where you define your products, where you define, for example, the resource-facing services definition. And because it appears in multiple domains, if you are conducting a meeting with the customer, or if you are the customer, if someone says catalog, this doesn't mean anything, because if you say catalog and the attendees are coming from BSS, coming from product domain, they will always think about product catalog. If you are talking about catalog and you're talking with someone doing service orchestration, or even someone in the service domains like core or radio, he will think of the catalog that exists in the orchestrator in his domain, for example, the radio domain orchestrator, core domain orchestrator, or maybe the service orchestrator. So you need to know exactly what kind of catalog are you referring to. And we will know the next slide that catalog is the main brick of any orchestration, regardless of its location. In the OSR, on the operational support and readiness, you start to see terms like service inventory, resource inventory, workforce management. So the inventory, okay, it's a very key term. And you need also to understand what kind of inventory in what domain, because there's an inventory in the cloud, there is inventory in the OSS, and there's also an inventory in the customer domain. So there are multiple inventories. And one of the most complicated projects that you might have in your enterprise is actually inventory federation or inventory consolidation, that you can have like master inventory that has all your service deployed, infrastructure, whatever. So that's the inventory. In the fulfillment, actually how you fulfill or how you deploy your service, you get terms like COM, customer order management, service order management, SOM. And COM and SOM are believed to be the borders, or define the borders between the team that's doing the BSS and teams doing OSS. So that's the borderline between BSS and OSS. And that's where you find solutions doing provisioning, okay? All generation of automation tool pushing configuration are all exist here. And then in the assurance, in the service domain, you find something like service problem management, service performance. For example, if you have a solution to get your CNF or DNF metrics, CNF or DNF fault management things, traps or whatever, that exists in that area. That's the assurance part of your service domain. And then in the customer domain, you see the CPM or customer problem management. That's actually where you get the customer ticket, customer handling, and you can easily map the customer issue to what's happening on the service and what's happening on the resources. In the billing and revenue, for sure, billing are very oriented thing to BSS. That's why you find all the logic, all the things happening on the customer domain, where you do the bill calculation and this kind of things. For sure, there are a lot of other what we call L1 application, but that will make the poster huge. I invite you to try to get it from Google. You'll find a lot of L1 applications. So these L1 applications, as I told you, it gives you a clue about what kind of products you need to purchase. For example, if I am a telco, greenfield telco, then most probably I see here, okay, I need a SOM, a service order management. Most probably I need an inventory. I need a solution to give me a catalog. So this is the blocks that actually defines what kind of products that you want to purchase. And also the teams itself, you find that the teams' names are very aligned with this kind of applications. You will find a team doing the SOM, team doing the COM, department doing the assurance, department doing the billing. So that's how we define the things. I will open the door for questions after 3 slides. So just to finish that topic, because it's a very foundational topic. Now we go and see where are the orchestration spots historically, like where did it arise from a telco perspective. So usually the customer order management, service order management, service order management, that's what we call a level 1 application. This application composed of multiple applications. Initially, the TM forum and even the telco understanding, we have always believed that we have a sense of orchestration that exists in the COM and SOM and the resource order management. Why? Let me just go to the next slide and explain to you why. So, for example, I took the SOM, the level 1 application, and I will tell you now what are like the level 2 application that exists under that SOM. So what kind of level 2 application that you may find it under the solution that providing the service order management. So service order management is something that will get a service order from the COM and from the BSS side, from the whatever marketplace. A customer will need to purchase a certain service, certain product that eventually will come to some sort of API, like please allocate this service to that customer. In a theoretical explanation of SOM you should have a capability to do. I will just pick the relevant one. You should have the capability to do service design, to model your service, to tell exactly that this service maps to this workflow. That if I get this service API, I will call that system to do X. I will call that system to do Y. And you know what? Once X and Y are launched, the service is completed, and I can tell the customer, now your service is up and running. I need to do service configuration. I need to push service configuration, not just to instantiate DNS. I need to push configuration. So service configuration is part of it. And also I need to do service activation, active and ready to be utilized. So all these logics and much more, vendors, they have their own great stacks of some. They have a lot of logics very aligned with what TMF here is suggesting. But if you go to service order orchestration, you see two important capabilities that exist at any orchestrator. That service orchestrator must have service order decomposition, that he gets a service order API, and then he to decompose that service order. For example, that he tell, okay, I get a service order to have a service called the gold service. I know from the modeling, from the catalog, that I need to do a decomposition of that service order to go to system X and system Y. So my southbound would be system X, system Y. I will contact system X by API, specific API, service order most probably, to come up with service X. And I will contact service Y or system Y to come up with service Y. And the service X and service Y together will compose the service that I want to allocate to the customer. So usually service orchestration gets one request for service and then decompose that service API to multiple southbound APIs to multiple systems to realize the service. That's a service order decomposition that exists at any orchestrator at any layer, regardless the name, okay? Service order tracking and management, I need to have a mechanism to understand if my service order is fulfilled or not. So I have to track the completion of the service, and if success or failure, I have to report that to the northbound system. So whatever we're going to explain in this session will always be aligned with that logic, okay? So again, orchestration was not something new, okay? The initial understanding that most of the orchestration logic lies in the SOM and COM and the resource order management. So it is the way you fulfill the service, the way you order a specific service to be made. In reality, the market orchestrator or the orchestration capability, it is somehow grouping multiple capabilities from multiple processes. So, and if you, for example, scan any orchestration solution in the market, you will find that that solution has the capability to do order management, capability to get a service request from northbound, decompose that service to multiple systems, and make sure that this service is fulfilled. It has a flavor of assurance. So any kind of orchestrator has some sort of assurance flavor. So for example, he can get metrics about the service. He can get alert about the service. And for sure, any orchestrator will have an inventory for that orchestrator. If you remember the NFVO had a network service catalog, had an NFVI and network service inventory, okay? And he has his own engines to communicate with southbound systems. So he also have this kind of labels, but NFVO thought to be, or ideally, part of the resources domain, not service domain. As you see, from TMF perspective, service catalog can be external, but in reality, all the orchestrators of the market, they actually include all these capabilities. So you get any kind of orchestrator will always have a catalog where you find the modeling of the service that are there. It always have an inventory. It is updated once the service is up and running. A capability to do service order management, pushing configuration, service decomposition, service tracking, and also a capability of service assurance. And moreover, like there are also now capabilities of AI doing analytics, these kind of things. So in reality, an orchestrator, if it is in the resources domain or service domain, customer domain, you will always have a capability that is actually grouping multiple capabilities from different processes, starting from the strategic infrastructure product, which is the catalog, till the assurance. I will stop here. Next slide, I'm going to show you the orchestration main bricks, what you will always find in any orchestrator, trying to sum this kind of guidance from TMF into reality. But I would like to stop now and get your questions and make sure that we are all aligned. You can use the chat if you want to just ask. I mean, unmute yourself and ask. It's okay. Okay. So can I get thumbs up if you're still, okay. Tamer?
Yes. Assalamu alaikum, Kareem, and everyone. Thanks a lot for the explanation. Everything's clear. Just because maybe this is the area which is I'm working exactly, Kareem, and thanks for all these details. It is really fantastic, summary about. But I'm really as a enterprise architect or working in the enterprise architecture for this new technologies like orchestration and so on. There are many kind of standards like TMF. TAM and ETOM, in addition to ETSI Mano, and I find it a little bit complicated to start handling all this new terminologies and new technologies with this kind of standard. With the operator has a lot of processes, which is some of them legacy and some systems are legacy. When I'm trying to map the new for example, orchestration or slicing, which is new 5G standalone technologies and something like this, we find it is very difficult to map to all this kind of standards like TM Forum and like ETSI Mano. So I need to have like what is the best practice when you are applying this kind of new standardization to legacy processes and legacy systems. Which one I should use, Team Forum, ETSI, or which is better, or what is the best practice? Thanks a lot, Karim.
Thanks, Tamer. It's really a wonderful question. Because the fact one of the issues that actually most of the telcos are facing whenever they try to embrace a new technology is actually how to have this new technology incorporated in the current enterprise architecture, preserving the processes or maybe adapting the processes. So it's a key point. So the fact is, one of the key facts of the cloud technology or orchestration technology is the existence of multiple initiative and community works and reference standardization groups. So there are a lot of entities contributing. So you have reference architectures from ECNFV. You have something called ZSM, or if I remember well, it's like the zero touch stuff. And you have the GSMA, you have the Metro Ethernet Forum, you have some recommendations from the ONAP, from the open source mono, and these kind of things. But in reality, most of these entities, other than TMF, they don't focus a lot about the enterprise architecture. They focus about the technology itself. Okay, so that's why the digital transformation programs, the one actually that you are working on, and the programs that are actually being embraced by all the operators, they cannot rely or start from a technical or a technology reference architecture thing. So TMF is a little bit different, okay? Because TMF, it lies the foundation of the processes, of the things, and also they are adapting and recommending other enterprise architectures like the ODA, the open digital architecture, whatever. So that's usually a starting point if you want to do a blueprint. Okay, so TMF is a very nice thing to have a blueprint. But when you try to mix that with the HCN view of things, that's things where things gets complicated. And truthfully, that's the difficulty and the good thing about the work of enterprise architects, that you need to understand the technology, you need to absorb all these reference architectures, and then you come up with your operator X reference architecture. And that's my recommendation, and that's what I do with my customers, that we can take feeds from HCNFV, GSMA, Metro Ethernet Forum, ONAP, OSM, but it's not like the old day we have to adopt it 100% blindly. We have to take that, skim that, absorb that, and then come up with our own reference architecture that's aligned with our ODA or digital architecture. So you need to understand all the telco reference architectures, and then you need to come with your own operator X vision and architecture, and then you make sure as your role as enterprise architect that this is aligned with your digital architecture, the one that you set as a blueprint from the beginning. So it might not be a perfect answer, but this is from my experience what is to be done. And also I will somehow cover that implicitly because I have some backup slides showing you the reference architecture from these entities, but this is my insight for that topic.
Thanks a lot, Karim. It helps a lot. Yani, thanks a lot. I believe this is the best thing, yani, which can fit us to be flexible to start managing as you mentioned to see what is the best fit and not mandatory to apply all this kind of standardization. Thanks a lot, Karim. Thanks.
Thanks, Tamer. And we have one question about from Sharif. Had the GSMA develop a similar model for telco? So GSMA is contributing, but it's contributing mainly in other tracks related, for example, to exposed APIs. So they are coming with like API based architecture, but it's not really hitting the enterprise architecture because GSMA is not TMF. The framework itself is not just for telecoms; it's for any enterprise.
Exactly, Karim. An apology if I disturb here. It is just like I came from telco, and I'm trying always to have this narrow view about architecture from the perspective of telco. So in 3GPP, we don't have anything related to all this service fulfillment and this stuff. So I moved to a little bit of GSMA. I didn't find something much relevant. I know about the APIs and open gateways, exactly as you mentioned, but I was always trying to find a similar way as you nicely presented, or try to map from the TM forum.
Yes.
I know it's a little bit tricky question, but
no. I put myself actually in your place because we all have the same things that But you know what? When you talk with the teams doing the OSS and BSS, most probably, or in 99% of the cases, they are very tuned and aligned to TM4 stuff. So you need to speak their own language for you to explain to them that they are going to integrate with an orchestrator, or that you are going to be a southbound for their systems. So TMF terminologies and thing is actually the language being used by these teams. Okay, so now the orchestration membrics, any orchestrator, the NFVO, domain orchestrator, RAN orchestrator. So one of the aspects of an orchestrator that you cannot use that term in the space. You cannot say I have an orchestrator. Most probably you have to put a word before the orchestrator to describe exactly what kind of domain that it orchestrates. So for example, if I used the word network orchestrator, then that's the way I interpret the term, that you are going to provide an engine that are going to orchestrate all the processes, all the activity, all the tasks inside the network. So if you say RAN orchestrator, core orchestrator, then you're doing the same under the RAN, under the core. So any kind of orchestrator in any domain will always have these bricks. First of all, the design time environment. You need to have a specific environment that enable your developers, the business owners or whatever, to model the service. What is the service to be provisioned? You have to have a template that says that, okay, I have service X. Service X, it maps to instantiating new virtual machines or two VNFs, and they are linked like that together, and they have this kind of resources requirements. That's in the resources level. So you need to do the modeling for your service. That's why any kind of modern orchestrator will always have what we call design time environment. You do the modeling, you apply on testing environments, and you do testing for your service. You certify your service on the infrastructure. So that's the design environment, and it has like full DevOps CI/CD pipeline and any other capability that actually allows you that once you finish that milestone, you declare that you are ready to apply this service in the what we call the real-time environment, or sorry, runtime environment, or the production or whatever. So design time environment is a set of tools, set of practices that you use to model the service, test the service, validate service, activate service, sorry, certify service, and then declare your readiness for that service to be applied on the production. Second thing, that you will always have what we call a runtime catalog. And you might have heard that term. We always use the term catalog-driven orchestration. Catalog-driven orchestration, that whenever you service you modeled in the design time environment and you are sure that it is working fine, it's fine, you put said service in your catalog. And then you have now a catalog, like a menu. You can show it to your internal customers. You know what? I have this service available. If you want this service, you have to call this service by that corresponding API. So you will always have the catalog in any orchestrator. That catalog will always have the modeling of service, which is usually written by this kind of languages, Tosca, Yang. These are the descriptors. You will, in the case of cloud, you will have the CSAR package, the DNF packages that are already certified. It explains exactly this kind of service that you are modeling, how it is decomposed. So it explains to the orchestrator which systems shall I communicate with if I get this kind of service order. And the workflow actually is what to do as a step A, and then what to do in step B, and what if step A failed, what step shall I do? So this kind of workflow, it's all there in the system, in the service model, in the catalog. You get the life cycle management policies, how I'm going to scale the service, what are the triggers, do scale out, scale in, what is to be monitored, and other things like, and also what are the scripts to be pushed, the configuration to be pushed, what are the scripts to be followed. So everything you may find it in the service model, and you find it in the catalog. Here, I'm going now to talk about a very important topic. Any orchestrator, any customer aims to have an orchestrator that have a closed control loop. And closed control loop is as simple as that. Usually you do service provisioning, right? You instantiate a virtual machine, you bring up a VNF, you do a CNF, even you configure a certain service on a certain router, PE router. So you do execution, right? Then you have to monitor how your service is behaving, how your service is doing, the performance, the metrics, the KPIs. And then most probably at a certain step, when you monitor or you inspect a certain trigger, you need to take a corrective action. That you detect that there is a problem. For example, utilization is very high, CPU utilization is very high. Then you complete the loop and you do a corrective action of scaling, increasing a VMs, for instance. So this kind of closed control loop is a basic brick in any orchestrator. Any orchestrator must have a capability to push configuration, to provision. That's a very basic stuff. And then the capability either to monitor the environment or to take feeds from a monitoring entity and then detect that there is an issue, okay? And how we know that there is an issue? Because in the policies, the LCM policies, the triggers are mentioned, like if the CPU goes above 80, do X. If that metric of the number of attached user violated certain things, take action Y. So this kind of thing is actually the closed control loop. And then whenever the service is active or deployed, you need to update the inventory to know exactly what kind of service you are running now. And this service is composed of these virtual network functions, and these virtual network functions is composed of these virtual machines. These virtual machines are there on these servers. So you need to have this kind of top-down visibility, and that's an area where most of the vendors of the orchestrators are competing. Okay, so these are the orchestration main bricks. You find all these bricks under any orchestrator, and then I'm now looking forward to tell you like a very basic stuff about automation and orchestration. Okay, so usually these two teams are these two terms are being used somehow under different contexts, under same context. Sometimes they are used to actually map to each other or to define, like someone say orchestration, but he actually refers to automation and the other way around. So I have the basic example, the very basic example of doing orchestration automation, which is actually the when you go to the opera and you see this kind of huge musicians like doing stuff, and you have the maestro. So usually each musician, according to his instrument, like piano, guitar, whatever, he has some sort of a note, right? And that note says exactly what he needs to do. Okay. So there is a process for the piano that he needs to play this thing. That is a task, or this is a process. This is easily can be automated because if you bring a tool that can actually read this note and actually push it to an engine that delivers an audio, then you can simulate or you can automate the role of the pianist, because you can automate that one. You need to manual effort from anyone. You can do it. It's very easy. But the orchestrator at the same time, he's not just concerned about the piano. He's concerned about the piano and the drums and the flute. So he orchestrates who does what. So he does this kind of cross-domain orchestration. He actually communicates to different domains. Okay. So that's like a big difference. I mean, the automation is actually normally you automate a process, you automate a task, but the cross-domain is usually a function of an orchestrator. Okay. Another thing that if there is an error happening, for example, while the piano is playing, for some reasons, he made an error or the voice faded from the piano. So there should be an action taken by the maestro to have like another instrument up and doing another thing. just to cover what happened from the piano. So this kind of capability to detect that there is an issue and having a corrective action, that's usually an orchestrator. Is this not an automation tool? So classically, automation tool comes from the classic provisioning tools. That's a tool that can push configuration. So in the old days, someone should go put configurations on by his laptop. So the automation is understanding the language of the router or whatever, and then it pushes the configuration. So that's the classic thing of an automation tool. So these are the two main differences between an orchestrator and an automation tool. However, because it's a buzzword, it's a community term, so it depends actually on the context that is being used to. For example, in the automation, now they are doing something called event-based automation. Like something is triggered, event, then I do automation task. I push configuration. So that's very, very close to what the orchestrator is doing. Okay. The names of the products sometimes are misleading. So an orchestrator can be called an automation platform. Automation platform can be called an orchestrator. So what I explained is the definition from my experience from working with different tools, different customer, different use cases. It's not a Google definition. So orchestrator, most probably, it orchestrates multiple domains. So it controls what to be done after what. So that's the orchestration part. It can have, it can trigger incidents and have a corrective action. So they have this kind of policy engine that actually give them the smartness of what to do if this thing happened. Automation tool comes classically from a provisioning tool that it can push configuration. But sometimes automation tools are evolved to be an orchestrator, and other way around, orchestration systems. For example, in 2016, most of the orchestration solution on the market was all pure provisioning systems, provisioning solutions. So I hope I was able to give you some clarity about the term automation and orchestration. And it's up to you for sure to use the term in your domain, in your context, how to interpret that. Again, it's up to you. At least those are the main difference. Let me show you now just a quick note about the 5G orchestration framework, and I show you that there's a brick that I explained it there already in the 5G orchestration framework. And see, this was the orchestration framework suggested by release 15 of the 3GPP of the 5G, and that was the first time 3GPP talks about the orchestration framework, and it came in the context of network slice on actually how you provide network slice as a service to the end customer. So if you see on the left, the preparation, they called it preparation, design, onboarding, environment preparation. That's the design environment. That's actually where you do modeling for the service, you do the testing, you do certification, and then once it is certified and tested, you push that to the runtime catalog, and you declare that this service is ready to be consumed. So that's the first part. You see here in the life cycle management, life cycle of a network slice, you see terms like creation, which is commissioning, activation. So you see these terms, we saw that in the service order management or the order management. So that's these are like bricks also of orchestrator. I'm going now to tell you a very important concept and a very trendy term, which is intent-based orchestration or intent-based whatever, because it's being used by many other domains, other contexts like intent-based networking, intent-based automation, intent-based orchestration. So what is intent-based orchestration? I try to bring like an example. It's a little bit informative, but it maps to what we see in the. Let me just go to the other slide. Yeah. So what is intent-based orchestration? So intent comes from the intent. Okay. It's a term being used to describe a case where an orchestrator or a northbound system doesn't have to go into low-level details of a service. For example, if I need to provide a certain service, for example, I'm an operator, I'm offering a service called a gold edge, silver edge, bronze edge. And this is a service that's being provided, for example, to the SMEs, small medium enterprises. The gold service is actually about providing a CPE, customer premise equipment of the customer, giving him certain firewalling service, security service, and some commitment on latency or whatever. And then the silver and bronze are the same, but with lower quality of service or with no security. So these are the services that I'm actually selling to the end user. So let's say that end user, he went to digital channels, so to the operator marketplace, application, whatever, even he went to the shop, okay? And then he purchased a certain product. He purchased a gold enterprise edge. That should go from the shop or from the marketplace into the customer domain, into the customer order management, or to whatever processes in the customer domain. That will highlight what is the price of that product, whatever, and then the important part for us, we are people working on service domain and resource domain, that customer order management will send an API, a service order API, and by the way, TMF APIs are the one most used here. In the API itself, we refer to that request by something called CFS, customer facing service. And in customer facing service, because it's customer facing, you don't need to put much details about the service. Like, for example, I need to have a CPE to go to customer. I need to have this kind of security solutions. I need to have this kind of latency. No, this is not the way CFS are being modeled. CFS simply is just the name, like customer order management will tell service orchestrator, you know what? I need gold enterprise service. That's it. And he can just pass some variables, like variables that refer to customer IDs, some sort of identifier that can help the service orchestrator to structure a service. But at the end, in the service order API from the customer port, customer order management to service orchestrator, it will be intent-based, just intent. You know what? I need a gold enterprise service. And service orchestrator, based on the modeling of this service, because there is a catalog here, right? We all acknowledge that there's a catalog in service orchestrator that clearly say that this gold enterprise service is composed of these two subservices, and these subservices, each one of them have these kind of variables. So the modeling of service orchestrator, okay, and the way the workflow is defined mandates that service orchestrator will take this intent-based service and do decomposition and go to a network orchestrator, ask him for SD1 net 1, that's a service number 1, and go to a cloud orchestrator, potentially NFVO. You know what? I need NS security too. That's the name of the service that it is modeled at the NFVO. And when these two systems fulfill these two services, the service orchestrator will send a feedback or a service outcome that this service is provisioned. So intent here mean that customer order management or northbound system just sent the name that I need a called enterprise service and some variables, while service orchestrator did what we call customer facing service to RFS to resource facing service mapping. So now service orchestrator will talk to the resource orchestrator, and then in the RFS SD1 net 1, maybe it will start to put variables that refer to service, to resources, and the cloud orchestrator also, it will start to populate variables related to resources on the cloud. In the cloud orchestrator itself, there is a catalog, right? Because NMVO has a catalog. So in the NFVO catalog, there is a service defined called NS_security_2. And it maps exactly to what this NFVO need to do. For example, I will communicate with the Kubernetes. I will communicate with the OpenStack. I will create this network. So that's actually the way orchestrator communicate together. And this is the logic of intent-based orchestration, that northbound system shouldn't go into the low-level details of resources. For example, shouldn't tell the service orchestrator, you need to create this VLAN, you need to create this IP, do this MPLS stuff. No, just give you the intent And because you have the right modeling as a service orchestrator, you know exactly what to do. I hope this is clear, because you will always meet that team, that term in your work and in the whatever in the internet. Let me give you one complementary slide here, because most of the orchestrators now are evolving, adding AI ML capabilities. So I tried to group some roles for the machine learning here on the artificial intelligence. So for instance, instead, of having intent recognition in terms of APIs, it can be based on NLP, natural language processing. For example, the administrator can start to talk to you, like tell you, I need a certain service, and you ask him what kind of service. He tell you, I need a service, that brings X and Y to the enterprise. So instead of sending APIs, and I know that some vendors started to do that, you can even have the intent in terms of chatting. Okay. For the closed loop control that is part of any orchestrator, instead of waiting of something to happen to apply action, you can start to identify pattern, predict failures, and then you take preventive actions. So the closed loop happens, but in a preventive way, in a proactive way. Network analytics, you can get all the data that you get from metrics, from alarms, from whatever, and then based on that, you can start to come up with some sort of recommendation on how you optimize your network performance, serviceability, and how you enhance or you harden your security policies. Adaptive and proactive network control, that the more data you get, you can proactively change the network policies. And I will stop here to give you a hint. In the catalog, in the service modeling, I had something called policies. For example, statically, it is mentioned that if this virtual network function reached 80%, you need to scale out. You need to add a virtual machine, or you need to whatever add thing to do as a scaling action. But this is a static policy. If you have the right ML engine in your network, maybe that 80% static cannot be static anymore. For example, it's based on how you detect patterns, you reach conclusions. Maybe you can optimize this factor based on the machine learning algorithm. So one time it's 80, but now it's 70 because there are symptoms happening that shows that we need to do this action at 70 and not 80. So you start to have dynamic policies, and that's one of the functions of the ML machine learning engines that is being introduced to the orchestrators. I will give you an example, just an informative on the industry, to map the concepts that we are talking about. For example, I pick an old one from MEF, Metro Ethernet Forum, and Metro Ethernet Forum. They have an architecture for the UCPE or for the SD-WAN, Universal CPE, or for SD-WAN. What you can notice here, that the business logic, that think of it, this is like the marketing domain, sales domain, customer domain. That's northbound, and it integrates with the digital channels. This kind of legato, that's the customer-facing part. So I talk to the service orchestrator. I need to provide UCPE service to that customer. It's a very business stuff. Service orchestrator is the one actually who translating CFS, customer-facing service, into resource-facing service, and that's the Presto API. So Presto API, that's how we talk to the resources-facing domains. And this kind of Allegro, if you see here, you get the variable that you need to build your RFS based on self-service portal. Think of it that I'm an enterprise, so I have my business team, marketing team. He goes to the marketplace, and through this cantata thing, he purchased the service. And then my administrator and my technical team, they go to self-service portal and they put the variables. For example, what kind of technical variables that they can provide to get the service. Some sort of identifiers, some sort of quality of service requirements, whatever. So this will feed service orchestrator to talk to the resource domain, which is in that case the SD-WAN and the NFV orchestrator, and then that does the rest. So anytime you interpret or you read any documentation about the orchestration automation, or you have an architecture, try always to map the concept of customer-facing service and resource-facing service. Try always to map the concept of intent-based orchestration. Like, for example, that business application is not interested, to talk about CPU and memory and whatever. He just want to declare his intent, the intent, and that's what the business application does, or even in the telcos, the customer order management. Okay. I think we are already now it's already 1 hour. I will leave now the door for questions, and then I will have one activity to share with you. So please, if you have any questions, feel free to open the mic or to post it in the chat. Okay, a question about how assurance can be done using mobile Cordio. I will take that offline, because my plan is actually to tune the next session based on the question and based on the group requirements. So most probably we will have like 2 sessions, and then we will have like very specialized sessions to wrap up and answer your exact requirements and close the problem. So I will take this one as an offline, like how assurance can be done using mobile Cordio. So we can tackle that. Okay, so
Karim,
please.
sorry. Can we have live examples from operators that already running the full automation for the service, starting from slicing, for example, in Europe or Saudi? Can you show us something like a real example of requesting a service and how it's going?
Okay, so in order to have 5G splicing, basically you need to have a mature 5G SA and a mature pipeline for enterprises, for example. And this is not the case currently in the whole telco operators or telco community. So it's not happening. But there were some POCs. Okay, so this is number 1. Number 2, for me to bring a case and start to talk about it and do this kind of technical assessment, it must be available online. Okay, because I cannot leak, or I cannot bring anything that's not I'm not authorized to bring. So
Yes.
So I will, and if you can help me, if you find any kind of press release or a blueprint, something talking about fulfilling slicing in production, even in a pilot, I'll be happy to bring it, and then we can assess it together, because you will just simply map these concepts into the use case.
No, I have some work with Telefonica UK before, so I think they are applying some. They already have SA, and they already applying some automation for slicing and so on. So let me search if I can get something online or published for this one, so we can share together.
That would be great, and they're very aligned to my plan. I was planning to actually focus on use cases, reflecting these concepts in the coming session.
Yes, because the theoretical point of view is very good, and you are trying your best to describe with all the whole process. But I think the practical one and the real example may be a little bit different, or even to put it into action will have a lot of different aspects, right?
It's a good point, because what I'm explaining, it's not being perceived by the community as standard. What does this mean? It's not 3GPP that should be strictly followed. Usually the automation orchestration, you have the capabilities and you need to come up with use cases. So if that use case is to be, for example, realized using that architecture, then it's fine. If not, then it's also fine. you can come up with your operator X architecture that fulfill your use cases. So now the architectures, because it's became service based, so any system can communicate with any system. It became very loose and agile. So you can build your own architecture to guarantee the delivery of your, so you need to have some sort of pipeline that have multiple service, multiple applications from the enterprise, from the consumer. So you need to tune or build your architecture to be a catalyst for these services. It's not something like a goal for operators to build an architecture aligned with standard, and at the end they find themselves locked. They cannot even provide service. So that's why I'm sure 100% that what's happening on ground is different, but the concept is the same. For example, the split between customer-facing service and the intent base, it is there. But maybe a product, for example, can, if you see my mouse, can combine service orchestrator and NFVO in the same block. Then it will be one block. Maybe an operator that is actually a vendor that excels in the BSS can modernize the customer order management to be also a service order management. So you see a lot of things. Maybe for example, one enterprise service, because of the heat from the enterprise, we couldn't do that on our private cloud. So we had to build another cloud stack with another capability to perform this thing, and that violated somehow the architecture of the operator. So at the end, business is the catalyst.
Agree, totally agree.
Okay.
Kareem, actually, I was going to ask the same question. Maybe if we can have just an example on like a domain orchestrator on the cloud, right? I mean, Service X, nothing specific to a customer or anything. Okay. What parameters are we looking for? How we're going to push that from cloud perspective? Okay. I mean, not from end to end, not like 5G SA, not the big picture, just the focused one.
Okay. I'll try to have that somehow in the next sessions. I'll see what is available, what can be shared, and hopefully can do that. I see, Fatin, you're referring to the EAND case.
Yeah, Kareem, for the use case, I think the team here was asking about a slicing use case. So there was an announcement from EAND before Mobile World Congress about the slicing use case across fixed and mobile subscriber. So I'm not sure if this is relevant, but I think it's compromised the full stack of Orchestrator, then domain controllers, and it's public.
Okay.
And I think it was with Microsoft also.
Yeah. So I would see the press release or the whatever available online. I will because Salat is my direct customer, and also Nesma is here from Salat. So I'll see what are the borders that we have to somehow I will see the publication, Fatin. If it has relevant information, enough information to be discussed, I will do that. If not, then most probably we'll try to find another maybe reference, not from the region. Okay.
Yes.
Okay. So let me stop here. I will stop the recording, and then I will show you an activity that I would like you to work on. And I will also talk about some maybe use cases. But yeah, let me just stop the recording here. I would like to thank you all. I will continue. Please do not drop.